All right, you had 3 questions on page 151. Number 26 says, what is the mass of a sack of potatoes that weighs 1.1 times 10 to the 2 newtons? So Fg is equal to 1.1 times 10 to the 2 newtons, in other words, 110 newtons. What is the mass? Okay, we're assuming that we're on Earth because it doesn't tell us otherwise. So Fg equals mg. So m is going to equal Fg divided by g. 110 newtons divided by 9.81 meters per second squared. You should get a mass of 11.213 kilograms. Okay, number 27. If you weigh 541 newtons on Earth, so Fg on Earth, 541 newtons, how much would you weigh on the Moon and on Mars? So before you can do Fg on the Moon and Fg on Mars, you need to find out what your mass is. Okay, so you would do Fg equals mg. So m equals Fg over g. You need to find out what your mass is because your mass doesn't change. Your weight will, but your mass won't. So they're telling us the weight on Earth, 541 newtons, and we know the acceleration due to gravity on Earth is 9.81 meters per second squared. And so when we do this, we find our mass to be 55.1478 kilograms. Okay? And so now we can use that to find out what's our Fg on the Moon. So Fg is equal to mg. So Fg is equal to that 55.1478 kilograms. And look up on page 133, the acceleration due to gravity on the Moon. It's 1.64 meters per second squared. And when you multiply this out, you should get 90.4424 newtons down, obviously. Okay? Part C wants you to do exactly the same thing, but for Mars. So again, Fg will equal 55.1478 kilograms. Look up Mars on that same chart and find out the acceleration due to gravity on Mars is 3.72 meters per second squared. And so when you multiply it out, you end up getting 205.1498 newtons. That is the third part of that question. All right, number 28. Says, how much would a 4.6 kilogram rock weigh on Jupiter? So our mass is 4.6 kilograms, and we're looking for our weight on Jupiter. So again, you need to go to page 133 and find out that little g for Jupiter is 25.9 meters per second squared. So then Fg is equal to mg. So Fg is equal to 4.6 kilograms times 25.9 meters per second squared. Type this together. I didn't do this one beforehand. 25.9 times 4.6. And you should get 119.14 newtons. Clearly, the gravitational pull on Jupiter is much stronger than the Earth, 25.9 compared to 9.81. Okay, so hopefully your work with Fg is pretty good now, and now we can begin to introduce other forces.